Okay, hello everyone. My name is Magda Stożek. I'm very happy to be able to talk to you today about implicits and Scala free. Now, I have been a Scala developer for 5 years now. And right now I can say Scala is a great language. I enjoy it. I like writing it every day. But the beginnings, they weren't so smooth. I kept struggling to understand various concepts of Scala, and one of the things that confused me the most was implicits. There were times where I thought, okay, I've got this. I understand implicits. And then, sometime later, I came across some other usage of implicits, and I was lost again. And I had to circle back to my more experienced colleagues and tell them, okay, I know we have talked about implicits, but can you please explain to me one more time what is happening here in this context? Fortunately, my colleagues were very patient, so I got through this difficult phase, and I didn't give up Scala altogether. But I kept thinking, why does it have to be so difficult? So when I heard about Scala free, and I heard that the concept of implicits was going to be completely redesigned in Scala free, I was curious. I wanted to know if that's a change for the best. So that's how this presentation came to be. I'd like to share with you what I have learned. So the plan for the next 29 minutes is I will tell you what implicits are, why we need them in the first place, why can they be so confusing in Scala 2, and the main part of the presentation will be 7 use cases of code, Scala 2 and Scala 3 code, back to compare how the usage of implicits or contextual abstractions is different. And then I'll finish with a couple of words about migration. So why are we talking about implicits? Implicits make us powerful. They are a very useful language feature which defines so-called contextual abstractions. So that your code doesn't run in void, it runs in some kind of context, and because of that, you don't have to write everything specifically. You may want to decide that this is something for the compiler to infer, and that's why it's called contextual abstraction. Apart from providing context, implicits are used to add functionality, to define type classes, which are an important feature of itself, to provide implicit conversions between the types, to handle dependency injection, to express some capabilities, compute new types out of existing types, or proving to the compiler some relationship between the types. So that's one keyword for all those functions in Scala 2. So also, apart from being powerful, implicits also make us miserable. And one of the main reasons why this is, in my opinion, is that you can see the implicit keyword in all those, next to those language constructs. So you can have implicit parameter, argument value, object, def, and class. And it's not like they map one-to-one to those use cases or functions from the previous slide. You actually have to know some idioms, some ways of how those things are defined. So it's not like you have a look at the keyword, you instantly know what happens. You need to have some background knowledge about that. Also, there's the problem of imports. So if you have used Scala and implicits, it may happen to you that you have some Scala code, it compiles, it's fine, and you copy it to another file, and then the compiler isn't happy, it doesn't compile. And often what you are missing is this one import which fetches for you some implicit value for the code to work. And sometimes in this long list of imports, it's really hard to see which of those you have to copy. And when you finally find that import, your code magically compiles, it's all fine, so it almost feels like a magical import incantation. At least that's my experience, that's how I felt. On the other hand, sometimes you import too much. Sometimes you don't even realize that you have imported somewhere in the long list of imports some implicit conversion. So suddenly your code, your compiler, treats some type as some other type. And weird things can happen because of that. So for all those reasons, implicits can be confusing. Now, where does Scala 3 come to the picture? So generally, Scala 3 is a major language rewrite. It actually took 8 years from the first commit to the general release. But what's most important, in my opinion, is that the creators of the language or of the Scala 3, they have decided to listen what we say. to see how the code is used, how the libraries are built, how the repositories using Scala are built, and they have listened to our complaints. And they have decided to identify and fix the tricky bits, to make it a language which is easier to use, more handy to work with every day. So it's probably not a surprise that implicits have been identified as one of such pain points. And this concept of implicits is completely redesigned in Scala 3 to the point that this implicit keyword is gone altogether. You won't find it in Scala 3. What do you get instead? Is you get a couple of new language features, which each of them does one thing and does it well. So let's see it in action. I have prepared 7 use cases, which in my opinion are the most important or most widely used. The first one is providing context, then adding functionality to your types, defining type classes and why we might use them, provide implicit conversions, and then a couple of words about imports, unused names, and compiler errors. So let's start with providing context. Let's say we want to have a future. So if we have the future, we have the body of the future, and that's really all that we are interested in. But you know that that's not enough, because you have to provide the execution context for the future to run on. So if you have a look at the definition of the apply method, then you can see that apart from the body, you also have another implicit parameter list, and that's still Scala 2, where you provide the execution context. And for the code at the bottom to work, you need to somehow provide the execution context. And in Scala 2, you can do it with an implicit value. So if you have such an implicit value, then your code at the bottom will compile. And now how is it different in Scala 3? In Scala 3, you are trying to have the same future, but if you have a look at the definition of the apply method, it's a bit different, because apart from the implicit keyword, which we are not allowed to use anymore, we have this using keyword. And in the place where we provide the execution context, we have the given keyword. So this pair, using, which we use in the definition, and given when we give the actual value to the compiler, is the most important pair for providing contextual abstractions in Scala 3, and something that you will use the most often. Now let's take a look at adding functionality. So to explain that, let's imagine a sample domain. Let's say that we are working in a domain of website with book recommendations, so that you can add books that you have read, share it with your friends, and so on. And also there's this functionality of reading challenges, so that you can say in January that this year I want to read 20 books or 10 books, share it with your friends, see how it goes, and so on. But then you talk to your product owner and they say that there's a slight problem, because some of the users, they add very short books. So they have those long reading challenges, they finish it in January, and it's not so fun for everyone anymore. So you decide to add a qualifies for challenge method to your type. So the book type is your entity, your type that you work with, and you want to add this qualifies for challenge method, so that a long book qualifies for challenge, a short book doesn't. But the problem is that the book class is defined somewhere in another package, it's closed, you cannot really add a method to it. So what you do, in Scala 2, to add such a functionality to a closed type, you use the implicit keyword. So you provide an implicit class. It has some name, it operates on the book type, and here you define the method that you want to extend it with. And if you have such an implicit class definition in scope, then in Scala 2, the code below will compile and will work fine. Now, how is it different in Scala 3? What you are trying to achieve is the same thing. So you have the closed book type, and you want to add the qualifies for challenge method. But what you do is you have a brand new extension keyword. So that's a new keyword in Scala 3. Extension working on the book type, and again, you define the method that you want to add. So the great thing is, whenever you see this extension keyword, you instantly know what's happening here. You know that you are adding some functionality, some methods to a closed type. So that's, in my opinion, much clearer. And now let's talk about type classes. So type classes are an important language feature in general. And again, to define why we might want to use it, let's go back to our domain example. Let's say that, again, you talk to your product owner, and it turns out that some of the people don't read such a lot of books, but they read a lot of articles, and they would like to take part in the challenge as well. But how do you compare it? Reading 20 books isn't the same as reading 20 articles. So you decide that now you are going to have a score. So there's a current score of the challenge. And depending on whether you add a book to the score, if you add a book, then you add the number of pages the book has. And if you add an article, then you have 1 point, as if each article had just 1 page. And then you can somehow compare it together. So how can you go about that? To have those add item method, which would have a different behavior, depending on whether you call it with a book or with an article. If only book and article had a common parent, then it would be easier. Then you could work on the trait, for example, or the parent, and have the implementation per the children type. However, in our case, it turns out they don't have a common parent. So what you can do is you use type classes for that, because they can be used to define so-called ad hoc polymorphism, so adding common functionality to unrelated types. And in Scala 2, the way you define it is you have a trait. So our behavior is scoring, so that's the scorable behavior, parameterized by the t-type, by some type. And then the implementation of the type classes is, again, using implicits. Here it's implicit value, but you can use implicit object or def. Let's stick with val here. So we have the scorable book implementation, which is the implementation of the scorable behavior for the book type. And then the score method here is just the number of pages. And you have the scorable article behavior implementation. So we have scorable of article, and the implementation is always 1, is 1 for the article. And the way we use it is, let's say we have this current score case class. And what it does, it has the add item method, which is parameterized by the t-type, which is any t that implements the scorable behavior. And then when you add an item of such type t, then you take the current value of the score, and then here this implicitly of scorable is just saying, dear compiler, please fetch me the appropriate implementation of the score method according to the type that we were called with. So that's how you can use type classes to implement and use common behavior of unrelated types. And this is Scala 2. Now, how is it different in Scala 3? Where actually, that's before we go to Scala 3, there's also another syntax that you can do in Scala 2. If you don't like this context bounds here, so this t:\scorable, then another and probably more popular syntax for that is you can have another implicit parameter list when the scoring instance is, or scoring value is available to you to use by name. So that's just another way of writing the same thing. Now, Scala 3. We want to achieve the same thing, and to define type classes, the trait will be the same. So we have the scorable behavior that we want to implement by type classes. And we can implement the type classes implementation using the keywords that we already know, so given and using. So you give a scorable behavior for the book type, and that's similarly to Scala 2, you have the implementation depending on the actual implementation that you are defining. So scorable behavior for the book type, scorable behavior for the article type. And in the place where you use it, again, you have the current score and the add item method, which can be parameterized by this context bound. So nothing changes here. So that's any t implementing the scorable behavior. And here where you use it, instead of the implicitly keyword, you have the summon keyword. So even for such a small thing, the implicit keyword or prefix is gone, and it's replaced by the summon keyword, but it does the same thing. It fetches from the compiler the appropriate implementation. And also in Scala 3, you can do this other syntax, so that here you have this implicit parameter list, even though it's not called that way in Scala 3, but you have this using keyword and you have the explicit, let's say, instance that you can use. So that's how you would use type classes in Scala 3. Now let's move on to conversions. Let's say that we are still working on our book types, and we would like to print it to the user interface. And somewhere in our code, we have this print method, which has this unique, very special and sophisticated way of printing something to the user interface. And you would like to use it with books. However, the problem is that it's defined for items. And again, item is a closed type, the print method is a closed type, but still, you would really like to use it with books. So what you can do is you can provide an implicit conversion, so a way for the compiler to use one type when it expects the other. And the way we define it in Scala 2 is using the implicit keyword. You need to provide in scope an implicit method. Here it's called book2item, even though the name doesn't matter. It takes the book type, so our source type, and returns the item type, and the implementation just uses the constructor to tell the compiler how to convert between the types. Now, what do we get in Scala 3? What we want to achieve is the same thing, but our conversion, we have the given keyword, but what's more important is this conversion class. This is actually a new class in the Scala standard library, scala.conversion, that you need to implement. It's parameterized by two types, so our source type and target type. And then you need to implement the apply method on that. So whenever you see the implementation of the scala.conversion class, you instantly know what's being defined. You know that you are providing an implicit conversion for the compiler to treat one type as if it had the other type. So that's, again, much clearer. Now let's take a look at imports, so those magical import incantations. In Scala 2, such a code would compile. Somewhere there in this asterisk, in this package, there is the implicit provided that we need. That's fine in Scala 2, but the same code doesn't compile in Scala 3. It will give you an error. That's because for the implicit imports or the given imports, there is a special syntax. You have to have this given at the end of your import line. And that's to make the implicit imports more explicit. So that right now, when you have this long list of imports and you are looking for the one that you need to copy to your new class, then you can only look at those which end with the given keyword. So those are the ones that provide to you some kind of implicit or given values. And if you really do want to import everything from a given package, then you have to use the syntax like this. So given colon asterisk. So that's, again, a bit more clearer, in my opinion. Now let's look at unused names. That's one of my favorites, and I think the smallest improvement, but I love it. So let's imagine we have a list of books, and we would like to sort it before we print, for example. So we don't want to reinvent the wheel. We can use this sorted implementation from the sequence trait if you are working with sequences. And the way this method is defined is it takes, in Scala 2, an implicit parameter list, because you need to provide the ordering, because the compiler doesn't know whether it should be ordered by name or by number of pages, and so on. So to provide such an implicit, here, for example, we are providing a by title value, and then all the compiler really needs is the types. So ordering of the type book, and then when it has two books, it just compares their titles. So you may notice that here we don't ever use this name, and the compiler doesn't use this name. Well, all the compiler needs is the type. If it has an implicit of such a type, it will know that it needs to use it in this case. And in Scala 3, you can have the same thing, so you can have the name, but also you can omit the name. And for me, that's a great thing, because I'm the type of person who overthinks names. So if I have to give a name, I need to talk to my team, decide on a convention. Are we using one-letter names? Are we using meaningful names? And so on. And here you just don't have to do it. So it's one less decision in your programming day, one less thing which drags you out of your flow. So that's just a nice thing. And also compiler errors. In Scala 2, if you didn't get your implicits right, that the compiler tried to be helpful, but not so much. So for example here, could not find implicit value for the evidence parameter of such a type, but we don't know where. Something is needing an implicit, but we don't know what. So if you have a long chain of methods, maybe it's not obvious from the start which one of them needs the import. And in Scala 3, you have just that added. So here you have no implicit parameter of that type for the scoring parameter of the addIt method of the current score class. So now it's again clearer, it's not dragging you out of your flow. And even the compiler may try to be extra helpful and suggest an import that you might need. So in those trivial cases like execution context, it's just working out of the box, or where you're writing tests and are not concerned maybe with the right execution context, you just want it to compile, you can copy and paste what the compiler suggests for you. And sometimes it feels almost too easy. But again, it's making your day faster, more pleasurable writing Scala. So now that we have the 7 use cases, let's talk about migration. Because if the implicit keyword is gone, then how do you migrate? Do you have to migrate in lockstep with your libraries? So what if the libraries already migrated to given and using, and you are still on the implicits? That's for some time, for some grace period, you can use them interchangeably. So you can have in one code base methods, for example, defined using the implicits, and then provide those implicits using the given keyword, or the other way around. So we can mix and match what you like. And only sometime in the future, there will be an exception, there will be a warning saying that it's soon going to be deprecated. And then sometime in the future, I think that future hasn't yet happened. So right now you can still mix it, but sometime in the future, the implicit keyword will really be banned and it will give a compiler error. But we have time for that. So to sum up, the great thing about contextual abstractions in Scala 3, in my opinion, is that the code conveys intention, not mechanism. So that's actually, I think, consistent with functional programming, so that you write what you want to do and not how mechanically you want to do it. The most important pair is the given and using, but together with extension methods, conversion class, and the more helpful compiler messages and cleaner imports, I think it will make writing contextual abstractions a bit easier, a bit out of the box, so that you don't have to consult the documentation so much, you don't have to circle back to your colleagues to explain it to you, because it's a couple of new tools which do one thing and do it well. If you'd like to know more, there's also a feature called context functions in Scala 3, and they don't really have a direct counterpart in Scala 2, so I didn't include it. But if you're interested in this area, please have a look at that. Also, there's much more about Scala 3 in the Scala documentation, and when you are ready to migrate, then there's nice resources about where to start, which compiler flags to use when you are trying your steps with migration, and the steps that actually are worth following. And if you'd like to have a look at the code from this presentation, then there's 2 GitHub repositories in my GitHub, so you can download it and play around with that, see how the compiler behaves. Thank you very much for your time. If you have any comments or feedback, you can leave them under this QR code here or through the Devoxx app, as you prefer. And if you have any questions, then we still have time for that.